I hope you can see it now. So as said, I invite you also to connect during the presentation and to connect using this link. If you connect to WooClap with this extension IRQRUN, or if you use the QR code, you will be able to participate to the quiz. Let me just allow everyone to enter. There's still more people coming in. I hope there's no one waiting in the room anymore. So as soon as it's okay, I go. Okay, hopefully you are connected to QR. I see 67 people connected, so hopefully it will go. So it's my pleasure to present a presentation around sorting. We'll try to understand together how robots manage to sort waste better than we could do as humans. So today, yes, we'll speak about waste. So I looked at a few expressions to say waste in different languages. I think most of you are from Italy, if I'm correct. So rifiuti, I hope that's the right term for you. If you speak Swedish, you would say afval. If you speak Dutch, you would say afval, slightly different. If you speak French, you would say déchet, lixo in Portuguese, and many, many others. Let me see if there are some more participants trying to enter. I guess it's okay. So please make sure that you see the screen. Let me just check. I just have the problem with Anna who cannot hear me. But I hope for the others it should be okay. So please, I consider that you are all hearing me properly. So let me move on because I see time is flying. So the idea is to speak about waste and to discuss with you how we collect our waste and how we sort the waste. So we all have waste at home. This is just an illustration of the few different kind of waste that we might have at home. And I just want you to tell me how you sort into how many categories you sort your waste. So you can type it in the chat, or you can just eventually take the phone to tell me how many categories you have. If you sort your waste at home, do you separate white glass from green glass? Do you have to separate it? Do you separate plastics from metals? Do you separate metals from papers? Just tell me what you do in your different cities, in your different countries where you are. Okay, so, well, let me just say to move on that in Belgium, we have a collection scheme where we are invited to put our what we call PMC, so plastic, metal, and cardboard, into the same bag. So here, typically in Liège, we have the so-called blue bags where we put our PMC, which is plastic, together with metal, together with cardboard being typically the famous Tetra Pak beverage packs. So my question here now is, how would you then separate these different categories if you have to invent a machine to separate plastic from metals from cardboard? Because when these blue bags arrive at the waste processing plant, they have to be separated. So if you're ready with the quiz, I will invite you to answer the following question. I have it in the format of the quiz. So here it will start, this way. So you're invited to type your answer. Do you think we sort plastic from metals from cardboard? That we sort them by color? Do we sort them by density? Do we sort them by smell? Do we sort them by shape? You do not separate at all. Do you answer me? Okay, back to the question. I still have people coming in. I still do consider that you are able to connect. Okay, I see answers coming in for this question. I have up to 20 answers now, 21. So how do we separate plastic from metals from cardboard? I wait for a few more seconds. Let us see the answers. I think we clearly agree that the right answer is density. So indeed, we can easily separate plastic, from metal, from cardboard by using density. For example, that is what is done in the plants where we recycle end-of-life cars. You see here all these cars. This was a special case where you see we had all Toyota from the same brand. You see that the tires have been dismantled by hand. The seats have been separated, the batteries, but then at some point you cannot separate, you cannot dismantle everything. So the car is crushed in a shredder, and the car is shredded into small pieces of a few millimeters. This is a very small shredder. I can tell you, the company we work with, they can shred, they can destroy 5 cars per minute. 5 cars like this, these 5 cars in 1 minute, they are shredded into pieces of a few millimeters. And then all these pieces are simply separated into 3 categories. When you blow air with an air separator, you blow what is lighter than, so the lightest fraction, and this typically contains a textile, contains foam, contains paper, cardboard, and this is called the fluff. Then the rest, what is heavy in air, is then put into water, and we separate what floats on water, which is the category plastics, and what sinks into water, which is the category metals. So you see, it's not very difficult. This is just a simple density separation between what is blown away by the air, what is floating in water, and what is sinking in water. But now, of course, this metal category, as you can imagine, contains a lot of diverse metals. So I asked you now to think in terms of what could be all the metals found in this category called metals. So I invite you to name as many metals as possible. So if you're in the classroom, maybe you can shout a series of metal names. Just think that there are 91 metals in the periodic table. So of course, I think you think about iron, maybe you think about aluminium, but these are only 2. There are 91 other metals that are all mixed together in this fraction that is synced into the water. So I let you think about names of metals. Eventually you can type a few in the chat if you want. I see Armida. I hope it's going well.
Yes, thank you, Eric.
Okay, you're welcome. So think about names of metals, etc. And in my next question, I will invite you then to eventually link a few symbols, chemical symbols, to metals. So my question here, if you're ready with the WooClap, is to find out which one is not correctly associated. So in other words, which metal symbol association is not correct. So Al, is it aluminium? Is that correct? AU, is that for gold? NB for niobium, TI for tin. One of these 4 is not correct. So you're invited to vote to detect the wrong association, the one that does not work. I'll wait a bit more for more answers. So these are only 4 metals out of the 91 that we have. When I say in the periodic table, it means 91 metals that are stable on Earth and that form the Earth's crust and can be found in nature, in deposits, and most of them are mined because of their specific properties. Okay, I have up to 50 answers. I will show you the votes until now. And yes, of course, it's not such a difficult question. So I have 81 votes for TI. Indeed, TI is not tin, TI is titanium, titanio. For tin, which is stagno in Italian, it would be SN, as you hopefully know. Okay, so let's move on. Now, another slightly different question here. You see the different coins, the euro coins. Maybe most of you are using these coins, the 2 euro, 1 euro, the cents, and the 5 to 1 cents. So I'm just asking you, which of these coins has the color of copper? The color of copper. So this is my next question. Is it the 1 euro? Is it the 50 cents, the 5 cents, or none of these coins has the color of copper? Which one has the color of copper? So the 5 cents, the 50 cents, the €1, or none of them having the color of copper. So let me show so far where we are. 92% for the 5 cents. Excellent, good. So before I move on to that one, I will try eventually, if I manage to do so, to briefly have the camera back again. So I hope you can see me. Normally you should see me. I'm not too sure. Sorry, I'm a bit lost here. It's not too sure what you have on the screen.
Yes, we
Okay,
can
thank
see
you.
you.
So
Yes.
this is the color of copper. Okay, this is a copper ingot, a small one, because normally it would be like a 1 meter long. This looks rather reddish because it's slightly oxidized, so it's very red. But indeed, the color of copper is more orange, the orange color that we have on the 5 cent coin. Now, strangely enough, I guess most of you know that copper is not magnetic, but I have here a strong magnet, and you can see that the €5 coin, the 5 cent coins, is sticking to the magnet. So a mystery that I will try to explain later on. Let me share again the screen and continue with the presentation if it works. So my next question is indeed about sorting waste. You know that we are collecting a lot of cans. So typically we collect like 50 cans per person and per year. These cans are supposed to be easily recycled. So my question is, what metal are they made of? I ask you to think about what you think the metal is. And if you think that both are from the same metal. If they are from the same metal, these two types, then we don't need to separate them. So I guess most of you are answering aluminum because that's usually what most people think about cans. But let me just show you that I have two cans here with me. I don't know if you can see them, or maybe lower my camera. So I have two different cans. If I take again my magnet, you will see that this one is not reacting to my magnet, and this one is picked up by the magnet. I hope you can see it. Okay, even though the camera doesn't. Okay, so clearly there is a difference between the two, and this is because this one is steel, whereas the other one was aluminium. So it is not in every country, so I invite you to try at home with a magnet if you have cans which are magnetic or not. I can just tell you that in Belgium, usually most of our cans are steel, so they are magnetic, whereas these kind of cans, the more slim ones, they are made out of aluminum. In some countries, both are aluminum, so it depends. But exactly now, because we have two types of cans, as you can imagine, when they arrive at the waste sorting plant, they need to be separated, and this can be done using magnetic separation. So coming back to my scraps from the end-of-life cars that we are processing, remember that we managed to collect all the metals which were dense, they were sinking in water, but we have a mix of all types of metals. So the first thing we do is a magnetic separation, which is a very big machine. This does not really illustrate the size of the machine, but we have tons of shredded metal pieces that enter. If they're not magnetic, they will simply fall here, and they will go in the non-magnetic, which is also usually called the non-ferrous fraction, which is often named Zorba. And if they're magnetic, they will stick to the drum, they will stick to the drum, and they will follow this path and end up in the ferrous fraction. So this is an easy way. A big magnet is an easy way to separate magnetic fraction from non-magnetic fraction. Okay, let me just check if there is no one waiting in the room. I hope colleagues are taking care of letting people enter, which is very nice. Thank you for that.
Eric,
So, yes?
I manage the entry of our friends.
Merci, Martin. Okay. So, okay, magnetic separation is a very important step to separate the ferrous from the non-ferrous. Now, another strange thing you will see is that not every steel is magnetic. If you take a cooking pan as you have at home, maybe you will easily realize that most of your pan is not magnetic, whereas the bottom is magnetic. Again, let me try to show you this. I do have one with me, so I could show you in real time. If I take this kind of pen, hopefully, if I'm not too close, sorry, I see there is a problem of focus. Well, you will see that the whole pen is not magnetic, whereas the bottom is strongly magnetic. Okay, so definitely there is a big difference between the bottom and the side of my pen. So again, when we speak about recycling, it does mean that I have to separate the two. Why is the main body not magnetic? Because it is stainless steel and not just steel. So the bottom is steel, so 99% of iron, whereas the stainless steel here contains 18% of chromium and 10% of nickel. That's what we call stainless steel, acier inoxydable. I don't remember the name in Italian, but I guess you understand what I mean.
Inossidabile.
Inossidabile. Like you, Armida. Okay, thanks for that. So you see that the magnetic separation that I just mentioned will separate some steel, but not all the steel. So part of the steel is still going, the non-magnetic steel is also going with the non-ferrous, which makes things a bit more complicated. Okay, now let's come to some other question. Okay, you clearly found out that these coins, the 5 and the 1 and the 2 cents, are the color of copper. So my question now is, what are the others made of? And in particular, this yellow color, is it gold? Is it brass, ottone? Is it bronze, bronzo, or is it nickel? So the yellow colored metal of the different coins that we are using. What do you think they are? So I have 30 answers so far. Let me wait a little bit more. So to be totally exact, there is a slight difference between the yellow color from the 1 and 2 euros and the yellow color from the 50, the 10 and the 20 cents. But I will clarify what they are exactly. So I see that I'm again close to the 60 answers. So we'll start revealing the answers so far. So we are oscillating between nickel, gold, brass, and bronze. Majority is voting for brass. And indeed, the correct answer, if it works, yeah, the correct answer is brass. So ottone, what we call laiton, different names. Ottone comes from the name gold. I know it was Altun in Old Turkish, so the name ottone, the name laiton in French, refers clearly to gold, but it's not real gold as you can imagine. So let me reveal you what we have in these coins. The 50 cents are in fact 50, the 20, and the 10 cents are in fact what we call Nordic gold, but there's everything but gold. Okay, it's called Nordic gold, but it's essentially 90% of copper, 5% aluminium, 5% of zinc, and 1% of tin. This is an alloy. In general, the family of copper and zinc is called ottone. It's called brass. So it's a kind of brass, even though officially it's called Nordic gold. The yellow from the 1 and the 2 euros, this is Meyer short, which is closer to what we classically call ottone brass, which is 75% copper, 20% zinc, and 5% nickel. And the center of the 1 euro coin is called German silver, but here again there is no silver. So you see we cheat. The German silver contains no silver. The Nordic gold contains no gold. The German silver is 75% copper and 25% nickel. Now, to briefly come back to what I said before, the 5, 2, and 1 cents, which are, remember, they have the color of copper, but they have the taste of iron, because in fact, they are made of steel. They are 95% steel with 5% of copper coated on it. So the smallest pieces, they are essentially steel. That is why they are magnetic, and they are coated with a thin coating of copper. So they have the color of the copper, but they have the taste of the iron. So yeah, my question was, and I forgot to ask you the questions. You see the question here. So how would you separate these two coins if you had to find a way to separate these two coins? But okay, industrially, we have to separate, of course, different kind of alloys, a different kind of materials. You see here that if we need to separate the €1 coin from the €50 coin, the yellow color of these brass is too close. But of course, we have this German silver, which is a typical signature. So I wanted to bring you here to the importance of what we call optical separation, optical sorting. In industry, we are separating several materials just based on color. So you see here a camera. The camera is looking at shredded pieces, in this case of glass, for example. If you mix white glass and colored glass, there are systems in industry that will look at these fragments of glass and will basically separate them based on the color. Now, the camera can measure the color, but the camera cannot pick the different glass pieces. So it's like having an eye. You also need hands to be able to separate, of course, the materials. So what is done here in most industrial separating system is that you have a camera looking at those different pieces, and then you have an air blower, an air injection, which will blow away the particles we want to separate. So you see that here, the green particles, they are just flowing normally, but every time there is a red particle, the camera gives instruction to the air blower to blow it away into this bin, which is collecting the red glass. So this is done in most companies. The optical sorting is a very important process to, for example, separate white glass for colored glass. Here in Belgium, we are invited to separate the glass, but there are always people who do not do it perfectly. So we still need those machines to improve the quality of separation of colored glass and white glass. The same principle also applies for separating plastics, but this time plastics are not separated based on the color, because the color does not tell us anything about the quality of the plastic. What we want is to separate PP from PET, so polyethylene from polypropylene, etc. And I don't want to make it too complicated. Let's just say that it's still optical sorting. It is a camera. The only thing is that this camera is looking into the infrared, into the invisible part of the spectrum. So we cannot see it with our eyes, but the camera can see the different nature of the plastics, because we are looking, or the camera is looking into the infrared, and then the separation is the same. So you see that optical sorting is a very important process. Now let me come to another question about sorting, another technology that I would like you to find out. Let's imagine that we are controlling gold ingots. A gold ingot like the one you see here, so it's a 1 kilo of gold. It is exactly the size of your smartphone. So imagine that your smartphone is massive gold. If your smartphone is massive gold, it would weigh 1 kilo. Can you imagine? So now it's weighing typically 100 grams, but if it was massive gold, it would weigh typically 1 kilo. Now, my question is, imagine that one of the two here is a fake one. How can I detect that one of these two ingots is a fake one? Without touching, of course, you're not allowed to weight them, just by using a non-contact method. So the answer here would be to look through the gold ingot. And this is also what we do technically. You know, when you go to the doctor, if you have a broken bone, you will go to the X-ray machine and we will take a picture of you. With X-ray, we can see through your body, but not so much through the bones. Well, it would be the same with metals. We are using X-ray transmission. We are looking with X-rays through metal pieces to detect different metals. So we could do it with the ingots here. If one is pure gold and the other one is, let's say, aluminium inside, we would immediately see a difference of density of absorption of the X-rays. What you see here is that we are currently in our lab, we are developing systems to separate zinc sheets from the roofs. We're separating the ones that do contain lead from the ones that do not contain lead. And you very clearly see here when we look through the sheets with X-rays, you can see that we have zinc, which is more transparent to X-rays than lead. So every metal has a different density, and every metal will proportionally absorb X-rays. So my next question then has to do with density of metals. From all these metals, which one has the highest density, you think? So I suggest, so I'm looking for the one with the highest density. So I propose lead, piombo, aluminium, copper, rame, and platinum as a possibility. So which one of these metals has the highest density, which means which one would absorb most of the X-rays, which is also linked to the highest weight. If my smartphone was made out of that metal, it would have a higher weight. So density is, of course, also linked to the weight for the same volume. But here, speaking in terms of X-rays, so is it lead, is it copper, is it aluminum, is it platinum that has the highest density? So let us see. I have 40 answers so far, still a few coming in. Okay, we're coming closer to the 50% answers. So I will start revealing where we are so far. 67% for lead. Okay, no one voted aluminium. That's indeed one of the lightest metals. Copper and platinum. So the right answer is platinum. So we all think about lead because we know that we use lead to protect from X-rays, etc. Indeed, but some metals are even more dense than lead. It's the case of the platinum group element, with the densest metals are in fact osmium and iridium, for those who want to know. So we are at 22 with those. With platinum, we're at 21, whereas lead is only half of that. Lead is 11, roughly 11 kilo per cubic decimeter. So the right answer here was platinum. But of course, to protect from X-rays, we first use lead because it's much, much cheaper than using platinum. That would not be a very good idea to protect ourselves from platinum. Now, if we wanted to make a perfect fake gold ingot, so if we wanted to, I told you that with X-rays I can see through, but my question now is what would be the perfect metal to make a fake gold ingot? So I'm looking for a metal that would have exactly the same density as gold. Which one would you choose if you had to replace gold in such a way that it is not visible with X-rays? So the metal that has exactly the same density as gold, if you know. Of course, unless you know it, there is no easy answer here. I fully agree. And it's more for your information, and if you want to be perfect robbers, if you want to cheat the banks, I will give you the recipe. And this is a real story. I mean, there's a regular check to make sure that there are no fake ingots, and regularly they find fake ingots made of this metal, and of course painted with gold, so that they appear as being gold, but they have the taste of something else. Okay, I see 42 answers so far. So I will start revealing how many we have until now. Aha. So there is a competition between titanium and tungsten. Okay, I think tungsten is leading, and indeed the perfect answer is tungsten. So if you want to make a fake gold ingot, you have to take a mass of tungsten and paint it with gold, and at least with X-rays and with simple density measurements, they will not be easily detected. But okay, it's not a very good idea. Now, there are other things that we need to separate in industry. I will not go through all the things because I see time is already flying. But for example, we might want to separate these different types of batteries because they have different compositions inside. And so one example here would be to still use cameras, but this time to use cameras to take pictures of each and every battery cell so that we have pixels, and with the pixels we can measure the size and the shape of the batteries. This is something that we do in the lab also because we get mix of different kind of batteries, and we separate them first based on the shape. So we can separate the buttons from these more parallelepiped ones from the most cylindrical ones. You see groups of these red dots, these pink dots, and the blue dots, showing that all robots manage to differentiate different families of batteries based on their shape. Of course, the shape does not always tell what is inside, so we need more technologies to find out what is inside the battery, and that's where X-rays eventually come into play again. Now, think that you would have to separate these two pieces, okay? You would have to separate a mix of €2 from €1. Imagine that you have to develop a robot to do so. The question is then, what would you use? You will probably, of course, again, use a color camera, but you need something more because you need to be able to detect that the German silver is in the periphery here or that is within the central part. By the way, these two pieces have about the same ratio of yellow to silver, even though visually it's not apparent. Just for your information, it's about 50-50 or 40-60. So the way we would do today, if we had to separate these different pieces, would be to use artificial intelligence. So we train the system to recognize pieces that look like the €1 with the German silver in the center, with this Meyer short in the periphery. You can do it nowadays with your own smartphone. If you take a picture of a €1 coin in good conditions, then you enter it into Google Lens and you ask Google Lens to look into the big database of images in our internet to find coins that are similar. I did it here with Google Lens. I took this picture and he indicated me a series of images. So meaning that today, if you train the computer correctly, and Google Lens is a fantastic tool, you have artificial intelligence helping you to find other coins which are similar. Just for your information, Google Lens nowadays is based on more than 16 millions of images, so it's extremely powerful. So let me move on because we are using all these technologies, including artificial intelligence, in our modern world. I will skip this one because it's a bit more technical. If I had time, I would have spoken about laser-induced background spectroscopy. So will we even manage to detect the chemistry of pieces? But I want to move on. I have a few more questions, so I'll keep this one. So this is linked to this laser that we're using in the power of light. So just one more question about the energy of a light source. So the energy of the wavelengths. What is the most energetic light? Is it green? Is it ultraviolet? Is it infrared or is it blue? What is the most powerful lighting system? So exactly, I see ultraviolet, excellent answers. I have to move on because I see time flying. So sorry for those who have not time to answer. So ultraviolet is indeed what would look like. Now, one last thing about the quiz, and then I'll show you the video to finish. There is also metal in your sun cream. Maybe you didn't know. So my question is then, what do you think is being used in a sun cream to block the sunlight? So to block energetic light, the ultraviolet typically, because I just spoke about ultraviolet, you say that the ultraviolet from the sun can be harmful. So we put sun cream to protect ourselves from the energy of these ultraviolet rays. And therefore, in the sun cream, you have metal oxides. My question, is it titanium oxide, germanium oxide, indium oxide, or europium oxide? These are all 4 metals. Hey, the right answer is titanium here. Okay, so titanium is coming closer to, okay. The right answer is titanium. Titanium is used, 95% of our modern world titanium is used in white pigment, and titanium dioxide is a perfect protection against ultraviolet. It's the basis of all our white colors. Okay, I'd like to finish my presentation because time is over by just presenting you a short video of the system we've produced at university. We're developing it. Now we are close to an industrial scale. We have robots, those in green. We now have 5 robots. We are going to prepare a line with 16 robots. But what is important is the brain of the robots. Here upstream, you have a 3D camera, you have an infrared camera, you have X-ray transmission, you have LIBS, laser-induced background spectroscopy. Basically, all the technologies that I mentioned are installed upstream and are feeding the super brain of our system. So we're using artificial intelligence and all these sensors to properly sort different materials. I will finish with the video. Hopefully it will up. Oh, sorry, the video was not inserted. So I'll quickly go to the video. Sorry. Of course. I'm trying. Okay, here it is. Normally. Do you still see my screen? I hope so. So you see that we are working on separation of scraps from end-of-life vehicles, and our system is using all possible sensors to try to separate the best of all these scraps. So aluminium, zinc, copper, brass. You see here the flash of the LIBS, the laser-induced background spectroscopy. So I did not comment on that, but it's a laser which is flashing, creating a plasma, and we get chemical information. And you see our robots which are sorting in 20 different bins. So every robot can sort into 5 bins, and because we have 5 robots, we end up having 5 times 5, so 25 different categories. So it's of course a bit like a Rolls-Royce where we have all kind of sensors. Depending on the application, we can decide to put only 1 or 2 sensors, and we have sometimes easier cases. This is for the most difficult cases, like those fluxes coming from end-of-life vehicles, where there is a mix of plastic, a mix of rubber, a mix of different kinds of metals and alloys. And what is really important here that we try to separate alloys into different bins so that we can immediately remelt the right alloy. So we tried to avoid, of course, to mix aluminium with copper or zinc with lead, etc. So with this, I'm over. I've gone through what I wanted to share with you. I hope you managed to follow when it was more or less correct from a technical point of view. It is different to do. It's a bit difficult to manage the full system, but I hope it worked for most of you. So thank you very much for following my presentation, and you're welcome to send any question or to ask for more if you're interested. See you very soon, and hopefully in presential mode for another demo. Thank you very much to all of you.